Hey guys, during this video we are going to work on adding and subtracting scientific notation. You can use a calculator, you probably don't need one, but you do need to take notes. Now you don't need to write down every example, but you should at least be writing down 3 of the examples that I do here. Okay, make sure you push pause, rewatch, push play as many times as you need to. Alright, so these are the types of problems that we are going to be working with today. Alright, where we have 2 numbers written in scientific notation, and it says to add them. All right, now first thing I just want to show you real quick, it works out really nice when you're adding and subtracting if you have the same power of 10. So like I'm timesing by 10 to the 2, 10, or 10 squared. Okay, because look what happens if I work this out the long way. If I would just kind of write this out, I could move the decimal over twice. That would be 420. And if I did that here, moved it over twice, that'd be 350. Okay, and then I can just add them up real quick, and I get 770. So that's really what that equals. Okay, now I'm going to show you another way to do this. Okay, so this is the shortcut way that we're going to learn today. Okay, so first thing that you need to know is when you're working with these, you always want to have the same power of 10. Okay, and we do have the same power of 10 here. All right, so first thing I'm going to do is I'm going to actually rewrite this using the distributive property, and I want to show you how this works. If you guys notice, with both of these numbers, we're timesing by 10 squared. So what if I would write it like this? 10 squared times, I have 4.2 plus 3.5. Now I want you to watch what happens, and then I'm going to keep working this out. If I would distribute this, okay, using the distributive property, this would say 10 squared times 4.2. I could write that out. 10 squared times 4.2 plus 10 squared times 3.5. Now, that actually says the exact same thing as our problem started with. It's just written a little bit differently. It still says 10 squared times 3.5, and this still says 10 squared times 4.2. So our very first step is going to be to rewrite it using the distributive property. So I'm going to kind of redo that on this page so you can see. So what you first want to do is you kind of pull out the 10. They're both timesing by 10 squared, so you're going to rewrite it with the distributive property. Both things I'm timesing by 10 squared, so I'm going to have my 4.2 plus my 3.5. Okay, so again, all I did was kind of pull out the 10 squared because I'm timesing the 10 squared by both of them. It ends up giving me this same problem. Okay, now what you can do, once you are this far, it's actually pretty easy. All you need to do is add inside the parentheses. We can actually work that out. So if I work that out, 4.2 plus 3.5, looks like I get 7.7, so I'll just rewrite it, 10 squared times 7.7. Okay, now this just says times right here, right? So I can rewrite that in scientific notation now. I can write 7.7 times 10 squared. That is written in scientific notation, and you can see that because this number is between 1 and 10, and I have it as 10 squared. So I just wrote that in scientific notation. All right, let's try another one. Now, if you guys look at this, I'm doing 4.6 times 10 to the negative 3 plus 8.72 times 10 to the negative 3. So these both have the 10 to the negative 3. They're both timesing by 10 to the negative 3. So I'm going to just kind of rewrite that with the distributive property. 10 to the negative third, I'm timesing both things by that. So I can take my 4.6, and then it says plus my 8.72. Okay, now again, I just want to show you, this works because if I distributed this, it says 10 to the negative third times 4.6. That's right there. And then 10 to the negative third times 8.72. That's up there. Okay, now what you can do is you're going to work out inside the parentheses. I'm going to do 4.6 plus 8.72. Got to line up the decimals when you add. I can put a 0 there. It's 2, 13, 8, 9, 10, 11, 12, 13. So it looks like it ends up being 13.32. Okay, now here's what I have. I have 13.32 times, and you guys know that because it means times when it's right next to it, times 10 to the negative third. Now it almost looks like it's correct, except if I add, if I look at this, this is not written in scientific notation, okay? What I want it to be is 1.332. Okay, so I can't just rewrite it like that. I need to do times 10 to the something. Now remember, here's what I usually do. I look at this one and figure out, how do I get back to this? Well, I'd have to move the decimal over once to get back to 13.32. So this is going to be a 10 to the first. And then don't forget your 10 to the negative third right up above it. Okay, so I just brought that down. Okay, now I'm going to use my laws of exponents to do this last part. So I end up with 1.332 times 10 to the, if I look at that, 1 plus negative 3 would give me negative 2. So here is my solution written in scientific notation. All right, I would like you guys to try this one, so please write this one down. Push pause when you're ready to see if you got it right. Push play and you can watch me work through it. All right, so the first thing you guys should have noticed is they both say 10 to the 7th. All right, so I'm going to rewrite this. I'm timesing both things by 10 to the 7th. So I can write that as 10 to the 7th and then 8.2 plus 1.3. Remember, if I use the distributive property, it would get me back to this exact problem. Okay, now I'm going to add what's in my parentheses. So I have 8.2 plus 1.3. I really don't need a calculator for this. Okay, I get 5 and I get 9, so 9.5. Okay, now my last step is just to rewrite this in scientific notation. Remember, this just says times here, so I can write 9.5 times 10 to the 7th, and that is written in scientific notation. All right, so here is our next problem. Now, the first thing that you guys might notice is that this time the exponents are not the same. Okay, and that's going to cause a little bit of a problem, but I'm going to show you what we can do so that it still works out. Okay, so what you want to do when you have different exponents, you want to take the bigger one and try to rewrite this problem so that it has a 10 to the 5th in it. Now I'm going to show you how that works. I'm going to keep my 3.5 here times 10. Okay, I want it to have a 10 to the 5th. But I can't just change the 10 to the 6th to a 10 to the 5th. But what if I wrote it like this? Times 10 to the 1st as well. Now, let's just think about this. Did I change this at all? It still says 3.5, 10 to the 6th. Doesn't this equal 10 to the 6th, 10 to the 5th, and 10 to the 1st? Yeah, so really I didn't change it too much at all, okay? So all I did was kind of rewrite it. And then minus, I'll just keep this for now. All right, now I only want this part to say 10 to the 5th. I really don't want this 10 to the 1st. So what I'm going to do is I'm going to work out the 3.5 times 10 to the 1st. Now remember, it's multiplying, so it doesn't matter what order I do it. So I'm going to do 3.5 times 10 to the 1st. Now if I do that, watch what happens. If I move the decimal over, I get 35. So I took care of those two things. Now I still have times 10 to the 5th. Okay, minus, I still have over here 1.4 times 10 to the 5th. Okay, now look at this problem. Now do they both have the same exponent? Yep, they do. So I know I'm timesing everything by 10 to the 5th, so I'm going to pull that out, and with my distributive property, I'm going to take my 35, and it says minus, and then it says 1.4. Okay, so now what I'm going to do is subtract 35 minus 1.4. Oops, I better rewrite that. I'm going to do 35 minus 1.4. Okay, if I do that, if you want to, you can use your calculator. That's going to become a 10. That's a 4. So 10 minus 4 is 6. 4 minus 1 is 3. So it's going to be 33.6. So now I have 10 to the 5th times 33.6. Okay, now if you kind of look at that, 33.6 times 10 to the 5th, that is not in scientific notation. 33.6 is not a number between 1 and 10, so I need to rewrite that. I want that to say 3.36. Okay, I can't just rewrite it as 3.36. I need to rewrite it as 3.36 times 10 to the, well, if you think about it, to get it back to the 33, I'd need to move it over 1 to the right, so it's 10 to the 1st, and then I still have times 10 to the 5th. Okay, so my final answer is going to be 3.36 times 10 to the 6th power. Okay, and there is my solution. Okay, we're going to try another one. It says 3.5 times 10 to the negative 2 minus 6.6 times 10 to the negative 3. All right, first thing I notice is these are not the same exponents. Okay, so I have to kind of think, well, which one of these could I rewrite so that it had the other one in it? Okay, now in this case, I'm going to try to rewrite this so it has a 10 to the negative 2 in it. Now kind of watch what I do. I'm going to do 6.6 times 10 to the negative 2 times 10 to the negative 1. Now, if you look at those, if I had negative 2 and negative 1, if I put those together, it'd be negative 3. So I just took this, I rewrote it right here. This whole thing is still equal to that. Okay, and now I still have my front part, 3.5 times 10 to the negative 2, minus all of that in the back. Now, I only want to keep the 10 to the negative 2, so I'm going to work out this part, 6.6 times 10 to the negative 1. If I work that out, 6.6 times 10 to the negative 1, this tells me to move the decimal back one spot, so I end up with 0.66. Okay, so I'm going to rewrite this again. I have 3.5 times 10 to the negative 2 minus, I just got 0.66, okay, and I used all of this stuff here, so I still have times 10 to the negative 2. Okay, now if you look at that, that's good. I have both 10 to the negative second power, which is perfect. So now I'm going to use my distributive property and take that 10 to the negative 2 out, and I still have 3.5 minus 0.66. Okay, now I'm going to work out inside the parentheses. When I work that out, I get 10 to the negative second times 2.84. Okay, now if I write that in scientific notation, it's 2.84 times 10 to the negative second. That's already in scientific notation because this number is between 1 and 10, and then I have my power of 10. All right, let's try one last problem. Now right away, hopefully you notice that the exponents are different. So I'm going to try to rewrite one of them. I'm going to try to rewrite this one so it has a 10 to the fourth in it. So I'm going to rewrite this as 8.2 times 10 to the fourth times 10 to the first. Now again, I can do that because 10 to the fourth, 10 to the first, that makes 10 to the fifth. Okay, now I want my problem only to have a 10 to the fourth in it. So I need to get rid of this 10 to the first, so I'm going to multiply out the 10 to the first times 8.2. If I do that, 8.2 times 10 to the first, that 1 tells me to move the decimal over once. So I'm going to move it over once, I get 82. Okay, now all I'm left with is times 10 to the fourth. Now that's perfect because it's times 10 to the fourth. And I have plus 1.3 times 10 to the fourth. I have 10 to the fourth for both of them, which is awesome. So now, since I'm timesing both things by 10 to the fourth, I'm going to use the distributive property and write 10 to the fourth times 82 plus 1.3. Again, that works because if you distribute, that would give you this exact same problem. Okay, now I just need to add inside here. So I'm going to quick come up here and do 82 plus 1.3. Remember, you got to line the decimal up, put a 0.0. I get 3, I get 83.3. So I have 10 to the fourth times 83.3. Okay, now again, I'm just going to come over here. You could rewrite that as 83.3 times 10 to the fourth. My only problem is this is not written in scientific notation. I want it to be 8.33. Okay, now I can't just change that. I have to do it times 10 to the... Now think, how would you get back from here to here? Because these have to be equal. If I move it over once, that'd get me back to 83.3. So it's times 10 to the first, and then times 10 to the fourth. Okay, so now my final answer is 8.33 times 10 to the, looks like to the fifth power if I use my laws of exponents. And there we go. Okay guys, please make sure you rewatch any of the examples you don't get. Okay, so if you don't get something, go back, pick one of the examples, watch it, push pause, watch the parts you don't get, and listen to me explain it a bunch of times, okay? So if you think you got it, you can go ahead and go in Schoology and you can work on the worksheet that I put in there that is due tomorrow.